Okay, kids, this is kind of the big idea here in this whole section. If there's a part that I'm concerned about in section 3.8 for analyzing polynomial functions, it's this one right here, okay? If you go back to the beginning of your notes on Friday, we talked about odd and even functions. We said an even function was going to be a symmetric about what here, kids? Going to be symmetric about the y-axis, and an odd function is going to be symmetric about the origin. You can turn it halfway around the origin, okay? But we have some rules for this, kids. Rules for even functions and rules for odd functions. So I want to go back to this core concept, and I want to read this carefully. I want to make sure we have this down. I want to make sure we understand how to manipulate this to understand what's an odd function, what's an even function. So before I go into example 4, how about a volunteer to read my core concept here this morning?
Even in odd functions, a function f is an even function when f negative x equals f of x for all x in its domain. The graph of an even function is symmetric to the y-axis. A function f in odd function when f negative x equals negative f equals x for all x in its domain. The range of an odd function is symmetric about the origin. One way to recognize a graph that is symmetric about the origin is that it looks the same as a 180-degree rotation about the origin.
Okay. So identifying odd and even functions. So here we go with this right here, kids. First of all, example number 4 wants to know if this function is either odd or even. Now, guys, not going to sugarcoat this too much. What degree is this function right here? What degree is this function? It's degree 3, right? Okay. So what I want you to know is this. Degree 3, the possibility for this function is to be odd right here. Okay. It might be an odd function. When we talk about this, we're looking for symmetry about the origin. So we're going to check to see if it's odd right here because it's degree 3. Okay. Whoops, I didn't want to do that. Here's what I want to do. So we have a degree 3 function. So we're going to check to see if it is definitely an odd function. Okay. By definition, kids, an odd function occurs when f of negative x equals negative f of x for all x in the domain. So here's what we need to do. We need to figure out what f of negative x would look like. And what negative f of x would look like. Okay? We need to check those two things by definition. And if in the end they turn out to be exactly the same thing, then that's going to mean that this is an odd function. Okay? Again, it says right up here, a function f is odd if what, kids? F of negative x equals negative f of x. Okay, let's do the second part of this first, negative f of x. Negative f of x means go into your function and change all your signs. Okay, go into your function and change all your signs. So right here, kids.
F of negative x equals negative f of x.
Okay, so let's do the negative f of x first. Simply change all signs. This would become negative x to the what, kids? Plus what? Plus 12x. Okay, that's what that is. Now, if f of negative x equals the same thing, then you will know it's odd. Okay, so let's do the f of negative x part right up here. This is going to equal the following. This is going to become negative x to the third minus 12 times negative x. This is simply saying put negative x in for x. Well, guys, let's think about that negative x to the third power. It's really negative x times negative x times negative x. Okay? What's a negative times a negative times a negative going to get you?
Positive.
Negative times negative would be positive, and then back to a negative. So do you guys agree that right here, this negative x in parentheses to the third is really the same as, I'm going to squeeze this in here, let me get a different color, negative x to the third. And then help me out, kids. Negative 12 times negative x really becomes what? What would a negative times a negative yield there? Plus 12x. So this becomes negative x to the third plus 12x. Kids, how does the function in blue right here compare to what the other one was? They are the same thing. So does f of negative x equal negative f of x here? The answer is what? Yes. So down below here, I'm going to say since negative f of x equals f of negative x here, function is odd. Okay, that function is odd. Okay, so we say, well, it's degree 3, so we're going to check to see if the function's odd. So right here, kids, is the work for all of that. Okay? Now, just looking at decimals, what does this look like graphically? Okay? Somebody read that function that we just had. Was it x to the third minus 12x that we started with originally, kids?
Yeah.
Okay, so let me punch that in there. X to the third minus 12x. Kids, first of all, does the graph go through the origin? Does the graph go through the origin? Okay. Now, if I could take this graph and spin it halfway around, make half of a rotation at the origin, would this graph look the same? Yep. It would. Okay. This point down here and this point right up here, they would just switch. Okay. So if the graph goes through the origin, and you can say, ooh, I can make half a turn and it looks exactly the same, that's another way to say, oh, odd function. Okay? That's what it looks like graphically. So let's take a look and see what it means to be an even function here. Right up here, kids, it says a function is even if what? So basically, if I insert a negative x for x down here, is it the same as f of x? Okay. Well, guys, first of all, what degree is this middle function? What degree is this? It's degree 4. So we're going to check to see if the function's even. Okay. Do I need to check odd at all? Answer is no. Okay, so it's a degree 4 function. I need to know if it's even. Even functions say they're symmetric about the what, kids? Symmetric about the y-axis. Let's look at this graphically first. What's that second example say? X to the 4th. Okay.
Plus x squared minus stuff.
Does that look like it's symmetric about the y-axis? In other words, would the left half fold over on the right half at the y-axis? Yeah. So pretty good indication graphically that this is definitely going to be even. Okay, you could look at it graphically and say, well, it's even because it's symmetric about the y-axis. The y-axis is your line of symmetry. But if I had to prove this by rule, you know that g of x is equal to this mess, so we need to check g of negative x to see if I even get the same thing. Meaning right here, kids, everywhere where there's an x up here, replace it with what, kids? Okay, I'm going to squeeze this in down here. This becomes negative x to the 4th plus negative x to the 2nd minus 7. Now let's just think about this. Negative x to the 4th. That's like how many negative x's get multiplied together? 4 of them. But a negative times a negative times a negative times a negative is a positive. So this part right here in parentheses, this is really x to the 4th. Okay, let's check the next one. Plus negative x squared. But a negative x times a negative x would really be a positive x squared. So plus x squared. Oh my gosh. When I put g of negative x in, how does that compare to the original function g of x? Well, what was g of x equal to in the end? Same thing, yeah. G of x and g of negative x are the same thing. So it's kind of like saying when f of negative x equals f of x, it's what kind of a function? Even, okay? When I throw negative x in, do I get the same thing out? You bet I do. So that means that this function is what? Even. Why am I checking to see if it's even? Why am I not even checking to see if it's odd?
Because it's an even degree.
Yeah, it's an So we know that this one would be what here, kids? Well, it'd be even. Okay. Now let's check this last one. X to the 5th plus 9. First of all, what degree is this? It's the 5th. Okay. It's the 5th power. Okay, Parson. We better check to see if it's odd or even, kids. Let's check to see if it's odd or even. What would I check? Odd or even, kids? What degree is it? Degree 5. So we better check to see if it's what kind of a function. Odd, you bet. Okay, so if it's odd, we need to see if f of negative x equals negative f of x. Okay, well, let's do the f or h of negative x here in this case. Okay, kids, help me out. It's a 9 right there. Boy, this pen does not work very well anymore. Okay. Negative x to the 5th. Negative times a negative times a negative times a negative times a negative. Is this going to be negative x to the 5th or positive x to the 5th when you multiply 5 negatives out? It's going to be negative, you bet. So this is the same as negative x to the 5th plus 9. Now when I look at the other part of it, what defines an odd function, negative h of x means changes of signs and everything, kids. So this positive x to the 5th would become what? And this plus 9 would become equal to minus 9. Kids, are these two functions right here the same exact thing? They're not exactly the same. Is this function odd then? The answer is no. It's neither. It's neither, okay? And again, if I had to look at this graphically, read your directions again, or read the core concept. If I look at this graphically, an odd function would have to be symmetric about what? About the origin, meaning it probably has to pass through the origin. Okay, let's just look at this. What was it? X to the 5th plus 9, is that right, guys? All right, let's type that in there. X to the 5th plus 9. Whoops, what did I do there? Guys, in the first place, does this even pass through the origin? No. So if I rotate about the origin, all this stuff's going to, is this going to look exactly the same if it doesn't even pass through the origin, if I rotate it about the origin? Answer is no. Okay, so it'd be neither there. All right? So kids, what I'd like us to be doing here today then to finish up here, I sent out the new online assignment 3.8. If you have any loose ends from 3.6 and 3.7 to tie up, you've got a little bit of time to do that yet today. But if you have everything caught up, I'm going to have you get going